In this video, we're going to see how to find the inverse of a function that looks like this and check to see if the inverse actually is an inverse or not. Now, the first thing they tell us is that x is not equal to 1, and that's because if x was equal to 1, then you'll be dividing by 0, and we can't do that. That would be undefined. And the next thing it's saying is that it's 1 to 1, and what that really means is that it's going to have an inverse because, for example, every x value has only one y value. So if you look at something like this, an x value of, I don't know, let's make that a little bit better. Let's do a nice thing that looks like x squared, right? Y equal x squared. If you choose a value of, I don't know, -2, you'll get 4. But also if you did an x value +2, you'll also get 4. So this is saying it's 1 to 1. Every x value must have exactly one y value attached to it. So this is not 1 to 1. And this is, you can't do an inverse of this unless if you restrict the domain, because when you swap the x and y values, well, then the y value of 4, I should have drawn that a little bit better, which will become your x, is going to have 2 outputs. And if you don't understand what I mean by that, that's completely fine. I'll just leave that there for a second, and let's just start the process. So this is just saying that it's 1 to 1. Every x value has exactly one y value. Let's find the inverse. So to find the inverse, we have to swap the x and the y. Where's the y? I'm thinking of h of x as my y, right? So I'm just going to swap it. Well, let's write it first because I don't want to skip too many steps. Over x minus 1, right? All I did was I rewrote the function, but instead of writing h of x, I just wrote y. Let's swap the x and the y's. So the x will go here and put a y over there for that x, and also a y for that x instead. All right, now our goal is to get the y by itself. We want to get y equal blah, 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 blah. And how are we going to do that? Well, I don't want to say cross multiply because I hate that term. So let's just multiply both sides by y minus 1, right? Multiply this by y minus 1. I'm trying really hard to, this is a multiplication sign. Okay, so this x must get distributed in. So this is xy minus x is equal to, well, the whole point is to get rid of that. So that kind of just cancels out or divide out into 1. So we end up with 2y plus 1. Now, our goal is to get the y by itself. I notice a y over here. It's attached to that x by multiplication. See a y over here. It's attached to that 2 by multiplication. So let's move this x on that side. Let's move this 2y on that side. So we want to add x on both sides. And I want to subtract 2y on both sides because I'll cancel that out there. So we'll end up with xy, because remember that's x times y, that's a times, minus 2y is equal to x plus 1, or 1 plus x. Doesn't matter how you write that. Now, what do we do from this point? Well, we could undo the distribution of that y, right? In other words, factor out a y. So I'm thinking about this as, what could I have in here such that if I were to distribute this y, I would get that thing? Well, it would just be a x and a minus 2, because if I did y times x, I'll get xy. Y times minus 2, you'll get minus 2y, right? So just factoring it out. And let's get that y by itself by dividing by x minus 2 on both sides of that equal sign. This cancels with the denominator, and you remain with y is equal to x plus 1 over x minus 2. All right, so this is really my h inverse of x. I'm saying h because that's just what they named the function, right? They called it h. All right, so let's see if that's really an inverse. And how do you do that? Well, you have to do f, sorry, I just called it f when I know very well it's h. So we have to do h of h inverse of x. And hopefully when we do that, hopefully we get x. So I'm going to put a little question mark here. Do we actually get x? Well, that's what we have to check and see. And then you also have to do it the other way around as well. So h inverse of h of x. Right? And we want to see, do we actually get x? All right. So h inverse x is x plus 1 over x minus 2. So that's really the same thing as, well, I'm going to look at function h and replace x with this thing. So here's my function h. Wherever I see an x, I'm going to replace it with that thing. So that's really saying 2 times, this is going to look a little bit ugly, x plus 1 over x minus 2, but don't be scared. Never be scared of math. Always use it as a thing to motivate you. And the x down here, well, remember, I'm really replacing x with this. So that is x plus 1 over x minus 2. And then the minus 1 just stays. Now, how on earth do we do this? Well, the first thing I want to do, and there's a little shortcut that I use, is to get all the denominators of each of these little fractions into the same denominator. So in this case, I want everything to be x minus 2. And this is easy for these because I could just write the number 1 as x minus 2 over x minus 2, because anything over itself is 1. And the same thing over here. Let's just multiply this 2 with the numerator up here. So we have to distribute the 2 into everything. And if you're wondering, oh, how come we don't do it to the denominator? Well, that's how multiplying fractions work. You just multiply the top together and you multiply the bottom together. I put it over 1 so you could really see the fraction there. All right, so let's do that. So that's 2x plus 2. All right, all I did was I took that 2, multiplied it by that x, took that 2, multiplied it by that 1. All of that is over x minus 2. And because I want to get everything having that x minus 2 denominator, I'm going to rewrite that 1 as x minus 2 over x minus 2. Right? And if you don't know the shortcut I'm talking about, I'll try to like leave a description in, leave a link in the description with another video of why that is the way it is. Right? Like why that's a good strategy. This one doesn't change because it's exactly in the form that we want it to. It has the x minus 2 in the denominator. Minus, now because I'm going to change this one into a fraction, into multiple terms, put it in parentheses, x minus 2 over x minus 2. Okay, so because everything has the same denominator, we could literally just pretend it's not there, right? If you could get every single piece that had the same denominator, you could pretend it's not there. And now we just remain with the top, which is just 2x plus 2 plus x minus 2. All of that over x plus 1. Now, because this is a minus, and you have to minus this thing, you have to think about this as a minus 1, and we have to distribute that minus 1, right? So that's a minus x plus 2. And let's just see here. So we have this 2 canceling with that 2, right? Those 0 out. And you have 2x plus 1x is 3x over, now this x and that x, it zeroes out. And you have 1 plus 2, which is 3. The 3's divide into 1, and you remain with just x, which is exactly what I was checking for. Now let's do the opposite way. So h inverse of h of x. Now h of x is this thing. So that's 2x plus 1 over x minus 1. Is that equal to x? Well, let me just erase that. I didn't need to write the equal sign there. Really wanted to write an arrow. So I'm looking at h inverse, which is this thing. And everywhere I see an x, I'm going to put in 2x plus 1. 2x plus 1. So this is 2x plus 1. Right, sorry, not 2x plus 1. 2x plus 1 over x minus 1. So 2x plus 1 over x minus 1 plus 1 over, remember this x is really this thing. So 2x plus 1 over x minus 1 minus 2. And I'm going to do the same strategy that we did for this one. I'm going to make the denominators all the same. So I could, well, this one remains just the way it is over x minus 1. I could rewrite that 1 as a x minus 1 over x minus 1. All of that over to 2x plus 1 over x minus 1. Now, this is a 2, so what I'm really going to do is multiply by a number 1, but the version of the number 1 I'm going to use is x minus 1 over x minus 1. Right? Because x minus 1 over x minus 1 is the number 1. And if I multiply the number 1 by any number, I don't change the value. So that's all I'm really doing. And I have to take into account this little minus here, because I'm thinking about this as a negative 2, and now I'm going to distribute it with the top, right? Remember what I said, it's like a fraction. So this is a negative 2x plus 2 over x minus 1. Now, I know that might be a little bit uneasy for some of you, so let me just erase that and do it slightly differently. Gonna leave that as a minus. All right, and I'm just gonna multiply the 2 in. Right, so I'm gonna leave that minus alone, and I'm just gonna multiply that 2 in. So that's 2x minus 2 over x minus 1. Now, because it's a minus, I'm gonna put all this in parentheses again, right? So this minus will have to get distributed, which basically just changes the sign. All right, they all have the same denominator, so now we could cancel those out, and we remain with 2x plus 1 plus x minus 1. Right, when there's a plus in between them, it's not a problem. When there's a minus in between them, then you have to change the signs of the stuff behind it. 2x plus 1. So now we're going to change the signs. Minus 2x plus 2. Right? All I did was distribute that negative sign. And let's just see if things cancel out. Well, this cancels with that. So you remain with just the 3x on the top. This cancels with that. And you remain with just 3 on the bottom. And look at that. You divide them out and you get x. So, in other words, this function here is indeed the inverse of that function. We have to consider that x cannot be equal to 2 then, because if x was equal to 2, then this is undefined, and we already know in the original function x can be equal to 1. So we should take that into consideration. But overall, this is really what we were trying to do here.